triangles, that's a polygon that has exactly 3 sides, can be classified by the number of congruent or equal sides that they have. So if all 3 sides are exactly the same length, I'll indicate that by similar markings. We call it an equilateral triangle. All sides are equal. If our triangle has 2 sides that are equal and one that's different, we call it an isosceles triangle that has 2 equal sides. So if all the sides are different lengths, we'd call it a scalene triangle. It has no equal sides. We can also classify our triangle by the measure of their angles. So if it has one 90-degree angle or one right angle, we'd say it's a right triangle. If all the angles are less than 90 degrees, we call it an acute triangle. Now, if our triangle has one angle that's more than 90 degrees, we call it an obtuse triangle. So we want to tell whether the triangle is equilateral, isosceles, or scalene. So in the first triangle, all the sides are different lengths. So we'd say that's scalene. Here, 2 of the sides are the same length, and one is different. So we say this is an isosceles triangle. For C, all the sides are exactly the same length. So we call it an equilateral triangle. Now, if we want to classify our triangle as acute, right, or obtuse, for A, it has one obtuse angle, one angle that's more than 90 degrees, so it's an obtuse triangle. Here, all the angles are less than 90 degrees, so it's an acute triangle. For C, it has one right angle, and we indicate that with a little square box. So one right angle would be a right triangle. For 6, we have 3 intersecting lines, and we want to find the measure of angle X. Well, by examining the diagram, we see that these 3 intersecting lines form a triangle. So here's a strategy. If I can fill in the 3 angles in that triangle, angle X is supplementary to that third side. Right. So, for this angle, I know that that has to equal 105 because those two angles are vertical. They're opposite to each other and share only a common vertex. And vertical angles are equal. This second angle forms a straight line with the given angle of 140 degrees. So I know that those angles are supplementary. And supplementary angles have to add up to 180. So 180 minus the 140 angle that was given would be 40 degrees. So this angle is going to be 40 degrees. All right, so I have two of the interior angles of a triangle. I know the sum of all interior angles for any polygon can be given by the formula n minus 2 times 180. Since we're talking about a triangle here, well, n has 3 sides. N is equal to 3. So the sum of all the interior angles is 180. So to find this third angle, I have 105 plus 40 plus whatever that angle is, has to add up to that 180. So collecting like terms, I'll add the 105 plus 40 to get 145, and I'll solve for that angle. So that angle, that third angle, is 35 degrees. So if this angle is 35 degrees, what I said was that angle x was supplementary to it. So the sum of that angle, that third angle, plus angle x has to equal to 180. So I see that the measure of angle x equals 145. Now, quadrilaterals are polygons with 4 equal sides. So, these figures up to here are all parallelograms. A parallelogram is a polygon with 2 pair of parallel sides. So there's one pair, and here's the other pair. Now the opposite sides in a parallelogram are going to be equal. Now, a rectangle is a special kind of polygon. For a rectangle, we have 2 pair of parallel sides, so it's a parallelogram, but it also has 4 right angles. So it's a parallelogram with 4 right angles. So a square is another special classification of parallelograms. It has 2 pair, that's one, it's the other one, of parallel sides. But because it has 4 right angles, we could say it's a rectangle, but we can do better, because all four sides are the same length, we could call it a square. So a square is a parallelogram, two pair of parallel sides, with four right angles and four equal sides. Now a rhombus has, it's a parallelogram, two pair of parallel sides, so it is a parallelogram, but what makes it special is all four sides are equal. So the trapezoid and the kite, those are not parallelograms. A trapezoid only has one pair of parallel sides, so these are parallel. The other ones are not. Now a kite has two pair of sides that are the same length. So these are the same length, but they're adjacent rather than parallel, as in parallelogram. So these sides are the same length, but the sides are adjacent next to each other rather than parallel. So kite has two pair of adjacent equal sides. All right, so let's classify these quadrilaterals as parallelogram, rectangle, square, rhombus, trapezoid, or kite. So for A, see that only has one pair of parallel sides, so A is a trapezoid. For B, it has two pair of adjacent equal sides, so those two sides are equal. Those two adjacent sides are equal, so for B, that's a kite. C, it has two pair of parallel sides, that makes it a parallelogram, but we can do better with our description because all four sides are the same length. So C would be a rhombus. D, it is a parallelogram, two pair of parallel sides, but it has four right angles. So it's a rectangle, but we can do better because in that rectangle, all four sides are the same length. So the better description would be a square. E is two pair of parallel sides. Nothing else is special about E. So E is just a parallelogram. And F, we have two pair of parallel sides, but we also have four right angles and nothing more. So F is a rectangle.